Good morning. So as I said in the previous session, it's a good to bring your laptop. Okay, I'm going to do a lot of commands. You'll be looking at all this typing. That's how you may look at it. So it's better to type yourself. So the laptop's going forward. Next few sessions, 3 sessions or something. Okay. So I want to draw one diagram just to recap kind of what we, at least to cover that inode concept. So let's say one hard disk, right? This hard disk kind of logically inside, how it looks is that typically I expect the inode structure. So bunch of inodes. When you do format it, it will basically in the Unix environment. So it will have bunch of inodes, inode array, right? Everything else is free blocks, right? So everything else is basically a array of blocks. Really, that's all it is, right? This is everything else is free blocks of data. There may be something more, but these are the major pieces. Okay, so obviously when you format one disk, the minimum is one directory, right? When you mount it, it becomes an empty directory. Chances are that inode, first inode, either it's a 0 or 1, maybe it's a, let's say 0. Right, that first inode is the parent directory. So that refers to the parent directory, and it will be using a few blocks. I assume it will be using the first block, let's say. Right, that's the first block pointer. So this is where your directory, this is the first parent directory, I guess, the top level directory. Top level directory. So let's say we create one file in this new file system, right? If we create a new file, chances are that file will get the inode ID 1, right? Are you with me so far? So you get your inode ID 1. Not only that, let's say you create a file called ls.txt or something, right? So the data in the current directory, right? This is the current directory. It will have somewhere in there ls.txt with inode number 1. And this inode number 1 may be using this one, right? This is the kind of data. So that's a new file in the parent directory. Okay. The reality may be a little bit different, but the basic core concept is, that's how it is. So this, how does this inode array and refer this free, initially free at least, free disk blocks. Maybe I shouldn't say free now that we are using it. Initially everything is free, right? So maybe I should just color codes this thing. So now we have this allocated, right? Similarly this one is a file now, and this is part of that file. Okay, yeah, so now I can claim the original one is free. Okay. Remember, disk block size is typically very big, 8 KB, 16 KB and all, whereas inode array size, each one is like 100 bytes or something, typically. Okay, inode, each index, each block is only 100 bytes or something. Okay. So, how does this map to physical thing? Remember, in hard disk, what is physically, what is there in the hard disk? What do we call it? Sectors, right? So disk block, well, how does it relate to sectors then? Since we said disk block is 8 KB or 16 KB, several sectors together is one disk block, right? Typically, disk block is 512 or 1, right? 512 bytes or 1 KB. Maybe the new ones are different, maybe. So, used to be at least 512 bytes or 1 KB. So you have to do this physical to logical or logical to physical mapping. So multiple sectors together will map here. Similarly, this also can be like that. See, there can be maybe 10 or 12 or 8 inode blocks will together be in one sector or something. Okay, so all depends on individual block sizes. If the block is small, maybe multiple blocks will fit into one sector. If the block is very big, like in the bottom, then multiple sectors basically map to the one disk block. Okay, I believe this analysis we covered very much in detail in that Mint OS workshop, Mint Linux workshop in 2 weeks from now or something. Okay, if you're interested to know more, that's a good place to go to, that workshop. I think it's a Saturday or something. Okay. Okay. Any questions about this picture? New file system. Basically after formatting. Right? How it looks. Okay. Command line. Windows, you might have used a command line, right? Windows, you go here and you type in command, right? So eventually it finds it. So that's a Windows command line, right? You might have issued command like dir, or maybe what's the famous command you might have used? IP configuration, and even ls may work, no? ls is a Unix command. Sometimes they have that alias or something. So not much more, right? We may use few other commands, that's it, right? We're all kind of used to clicking and everything. So that's a command.exe. The older versions used to be called as command.com, old version. So there are two executables types, com and exe. I think exe is more popular now, so I think even, I don't know whether the com even exists anymore. At least the old Windows versions used to be there. Okay, so command.exe is pretty much the shell, right? That's how you typed it in there to come here. So the Unix, we have several shells, just like our so many distributions, several shells as well. Okay. Why there are several shells? Command line itself is pretty similar. Okay, it's not a big difference between the shells, but once you start writing scripting, it's a little bit different. This is the original. This is the bash is the original. In fact, that's our default in our shell too. Let's go here. We're going to open the shell. Yeah, just for fun, let's go to CS2. Okay. So let's see. PS command, process list or something it's called. PS. What does it show? Bash and PS. That means my shell is bash. PS minus F, it shows the kind of full command. Ignore this, we'll look into that more later. I mainly wanted to show that it is a bash shell. Okay, so bash stands for born again shell. Okay, come up with all this weird, I don't know why, that's born again shell, something like that. Anyway, so that's our default. There are several other shells too. So let's see here. C shell. people wanted the scripting to be C format. Okay, a lot of people wanted, because there were so much programming in C, right? Unix and C are so close, right? Okay, everything is written in C. Originally, a lot of coding was done in C and all that. So they wanted scripting also to be in C. So C syntax, okay? So they created, someone created this tool, TCSH. K-shell, I don't know what the motive was. They wanted something totally different between bash and other than bash and T-shell, so K-shell came in. I think you can easily navigate some command line up and down and all that, okay? Previous commands and all that. There are several more. It gets confusing because many times these shells have new version, includes the good thing about from other shells. So they all start to look similar too, okay? So bash, for example, is very different from shell, original shell, okay? So one of the properties, see, command line, up arrow, and there you go. Up arrow, just go to the previous command. So it's command history by pressing up arrow down. Or let's say you type in long command, but you forgot to create some input file. The command fails. You create input file and you want to run it again, you can simply press up and run it again. You don't need to type in everything, okay? Or you don't even need to kind of highlight and copy paste. You don't need to do that, okay? Remember, the Unix and Linux philosophy was, it was meant for writing a lot of typing directly, not even mouse. There was no mouse, okay? So that's why the commands are very short. You should be able to type in easily, okay? And with the arrow keys, it makes it a lot easier now, you know? So initially, of course, we won't type in any serious commands, but it's there, you know, when you do get to the serious commands. Okay, so K-shell. So now the bash I saw T-shell. Later, maybe when you do scripting, you will see the differences. Okay, these are, each one is written by different people, different organizations, so on. Okay, the scripting language syntax is different. Okay, so mainly syntax. Scripting language syntax is a bit different, okay? So why would you use the shell scripts? How many of you have used scripts for something? Scripts? Yeah. So why would you use a script? Python script, okay. When would you call something a script, not your program? Why would say something, this is a script and this is a program?
Script is a set of instructions and program is
Program is actually compiled. Typically, when you say program, C++, Java, and all this, C, you compile and run the executable. Whereas script, you run directly. You don't compile. It's kind of like when you're running, it's compiling each line as needed. Interpreter, also known as interpreter. Script is run by an interpreter. Okay, take it directly and it processes. It kind of does everything, all the steps together. So because of that, actually scripts can run slow sometimes. There are languages where you have interpreter and compiler, right? Java even has some environment like that, right? Some interpreter environment. What is that environment? Can you say something? Java virtual machine. Directly you can type it in. You have console. I guess. I have seen it. Even some IDEs support that. In the bottom, you can type it in directly. I forgot which one it was. Maybe JGrasp, I think. Anyway, so there are environments where scripting is directly you can do script and directly run it. That way you don't have that pain of compiling and all that. So the command line point of view, scripting does make a lot of sense. You have let's say you have some repetitive steps you have to do every day in Linux. So it need not be periodic job. It can be for any repetitive work. Repetitive work. So you type in those commands and put it in a script, you run that script instead, okay? Instead of typing in all those commands again and again. We can also use a shell script to trigger the periodic jobs. So my previous job in Samsung, what I was doing is I was in charge for network optimization, wireless network optimization. One other thing optimization requires is pulling in the data, right? The trend, right? So this data is pulled together automatically. In fact, every hour we used to send performance report. How particularly the networks that are deploying just now, we want to monitor very closely every hour, something going wrong, those type of things. So a lot of guys actually get report from me, from my email, automatically 24 hours a day. So they think that I'm working non-stop, every hour. So they tell me, wow, you never sleep. I look at them and say, yeah, that's right. So you can use the scripts for automated jobs. So my scripts will come on, it will do the FTP location, pull the files in, do the processing, send the reports out. Email with attachment. Nice looking, even charts you can do, So your manager will be very thrilled, So, okay, so you can do those type of things too. Of course, Windows has now timed tasks. What is that one? There's somewhere it's there, right? Control, somewhere I remember accessories. Where is that? So there's some periodic tasks or timed tasks or something. I vaguely remember seeing it. System tools, task scheduler. There you go. Scheduled tasks is what it's called in Windows. Okay. So what does it say? Schedule computer tasks to run automatically. Okay. So you can do that here too. Okay. So remember, they learned from each other. This came early. Unix came a lot before Windows. So Windows could see what are the nice features in Unix and bring it in. So that's what all these languages do, right? Languages or operating systems, whatever tools we build, you always kind of take the best out of existing tools and bring it in, right? Okay, so then you have this bunch of operators, okay? So let's play with that operators a little bit, and okay, that's why it's going to wireless. So now that I disconnected, probably my session is dead. Okay, let's connect again. Okay. ls command, list the files, right? ls, and let's say you want to create a file, and you can use the editor. Right, so I am used comfortable with the VI editor, but it will take a while. There is some links to how to learn and all that. So you can learn, use VI editor a little bit, just to know the bare minimum at least, okay? So let me go ahead and do a VI editor, okay? So I believe it automatically goes to command mode. So you just press A to append. See, now it's showing insert in the bottom, see? Okay, so you can type in, the spelling right? Okay, you can type in, then escape anytime. So I am back out of insert mode to command mode. See, now whatever, even I press the enter, nothing will happen, okay, because I'm in command mode. Again, you can press A or I to go to the insert mode, okay, and okay, I have to believe it before you guys believe. Anyway, so escape again. Then in the command mode, you can do this colon and do the commands, right? No file name, right? Quit, and we want to say something. First.txt. Okay, I know in the Windows environment, the extension is very important. Because when you click on the file, we want something to happen, right? That's what that extension decides, right? Right? So you do that, write and quit. So now you have that file, first.txt, and I can do ls minus l first.txt, ls minus I first.txt. That's inode number. That's a command line option, it's called. Minus I. In Windows, what is the option? Command line option? Slash. Very good. So dir w, dir slash, that's the command line option is slash. Okay. So here most of the commands use this minus as the option. So if you just say that, it just reflects, it says that yes, I do have a file called first.txt, right? If I make a mistake, okay, it says simply it doesn't have the file. Okay, let's see how many star.txt files are there. You can use the wildcard characters. You can use the wildcard characters. I'm going too fast. Guys who are trying to type in. Okay, I'll go try to go slow a little bit. You don't need to create that file and all that. You can easily create a file by just doing ls.txt, something like that. That's fine too. Okay, focus on the command line, not serious typing in or anything. Okay, just the command line focus on. Are you able to go to the command line? No? Okay, that's a separate problem by itself. Stuck in VI. Oh, stuck in VI. Escape colon. Okay, let me just close the session and restart. Universal solution. You don't need to reboot the machine, just to close the session. So you can press that X to close it and just if you get stuck. Okay. So another thing you can do is, assuming there are a lot of files, you may not have a lot of files. Actually, you should be able to go to my directory. How about that? Go do like that. CD space tilde character virasam. What that means is change directory to user virasam's home directory. That's what it means. So I told you, better to bring the computer. Okay, so by doing that, you'll be in my home directory. Now you can do something like this. You can use the wildcard characters. Star matches with all the everything, right? So there you go. So it pulls up all the files that have matching with the star.txt. Right? You can also see there are a lot of John files. Let's say ls John star, you can do that. And simply ls will bring all the files, simply display all the files. And you can see this color coding. So this color coding basically means that these are all directories. You know, those are directories. And there's another way too. I think F or something. Yeah, ls minus F. Indicate the file type. You know, indicate the file type, and that will show what type it is. See, that means it's a directory, right? I'll come to that and see here. A.out star. That's executable. How do I know about all this stuff? There are so many details. Well, let's see. Wow. There you go. ls min. Okay. So the command is ls minus minus help shows various options. My format is screwed up a little bit because I'm using really big font size. Yeah. I'll go back to bigger font size soon, okay? So ls minus minus help shows, see, how many options? Almost every letter is an option. So ls has this, ls takes the award for having so many options. Most commands are not like this, okay? Yeah, you have a question? You're okay? Still have problems, connection problems? No? Okay. Ask if you have some question, that's fine. So clear. Okay, clear is in the DOS window you use CLS, I think. Yeah, clear screen. And here CLS also works. Okay, CLS, clear screen. Okay, so let's see what else you want to cover here. Okay, so now I have students directory. This is something you guys will be using actually. Students directory, there's nothing there. So I'm going to let me go to students2 directory and basics. Okay, so I want to, so you have a few directories here, and ls minus students2. Okay, so students2. So basics, I want to copy the basics or move the basics. How about I just move it? Move basics. Basics is also a directory. I want to move it to under student so that you guys can see. Okay, I'll get to permissions a little bit later. Okay, don't worry about permissions for now. So now let's go to students directory. There is one basics, and go inside basics. There are a bunch of files. Okay, so there's C files and there's a CPP files. There are a few other ways you can match too. Let's see, C files. Okay, so these are all the files matching with the C extension, right? If I do ls star, of course it displays everything. It's very similar to just ls command. Okay, so ls star.c. Then let's say I want to match with only prog something. You can say prog something.c, prog star.c. And let's say, what else is there? Let's say I want only 5-letter files. You can do question mark. Question mark matches with 1 letter. Okay. So any file names that have the 5 letters then followed by .c. You can also write if prog.c like that, prog question mark.c. Let's say we have a file called prog 10, program 10. You can create something like this. Touch simply creates a file, that's all. 0 size file right there, 0 size. Okay, so you can do a touch command to create this file. You know what, yeah, what did I do? Touch prog 10.c. It's already there, so it doesn't really create. Okay, now when I do prog star.c, you can see the prog 10 is here. If I do prog question mark.c, will it prog 10 will it appear? It matches with only 1 letter. Okay, see. So these are most popular wildcard characters. I think there are a few more, and you can even do some regular expressions type of thing too. You can do ls prog 1 to 3.c like that. You don't need to know everything. I'm just showing. Okay. This level of detail and all you don't need to know. Okay, very rarely used.
Are all the regular expression
supported? I don't think so. I think to a reasonably limited regular expression, I think. Not all. That's a kind of simple regular expression, and then that's a full-fledged regular expression, right? So in fact, even the grep command later you will see, the grep searching for stuff, regular expression, there's 2 levels. Okay, so let's see, ls prog 1 4, that's on, yeah, that got confused because this is a very special character. Okay, so when you use some special character that has a special meaning, you have to do the backslash, just like how we do C++ or Java /n to avoid the in fact there we use a slash to give you a special meaning. So here we want to take away the special meaning and pass this in. Probably we are going too deep. Okay, so leave, that's not important. Okay, this is not important, this is not important. This one is good to know. Okay, so just to know those things, that's good enough for now. Okay, so then we want to know about redirection and that operators. You can type in multiple commands. Calendar. I don't think I need to explain that one. It's calendar output, right? This month calendar, and it even highlights which day is today. Okay, so for whatever reason you want to run calendar in ls, you can do like that. It displays the calendar, then ls output. One command followed by another command. Okay. Okay, what do you do to store the calendar in your file? Cal output redirected to. We call this a output redirection operator. Instead of displaying in the screen, try to always kind of say it in English, okay? Instead of displaying in the screen, you are sending to your file. Enter. Nothing obviously appears in the screen, right? So now you can do cat cal.txt. You can do VI, or if you are very worried about VI, nano, right? Nano or pico. I keep always get confused. So you can do nano. Then this is a lot more friendly. This is a notepad type of thing. You can see in the bottom how to get out. Any editor, first thing we should learn is how to get out, right? Okay. So Control X. Okay. So you can use nano for now. So this is the output redirection operator. Okay. How about if we run a command just by cat? It reads from the user input and simply outputs to the outputs to the screen too. Okay, it reads from the keyboard like that. Okay, it reads one line at a time and outputs to the screen. Now we can use that output redirection operator, and this is another way to create a file. Don't make many mistakes though. Backspace and all becomes very messed up here. That's why you should use editor. This is a very simple form of creating a file. Okay, as long as you have good fingers, you don't make mistakes. Okay. Small files, you can do that. Control D to indicate the end of file. Control D. Control and D. Okay. Control and D. Press them together to indicate the end of file. Okay. You guys can see, or should I make this bigger? Bigger little bit. So you can use a command like this to create a short files. It's not fun to type in with a lot using this. You should go to editor instead. Okay. So small files you can do this way. Or you can also do like this, enter, and basically copy paste from somewhere, right? That's another way. Okay, so I already created a file, and now I can cat that file. Cat. So when you do redirection, you are saying that whether that file exists or not, go ahead and write whatever I am going to type in to that file. Right? See? Now it's expecting me to give you an input. See? Okay? Then Control D. Control and D to indicate the end of file, end of input. In a new line. Typically you cannot do it in the middle of the line. Okay. Okay. How about input from your file? cat. See, if you do cat data text, that itself does that job, right? So it basically gets the input from that. You can also write like this. Read the input from this file. The cat command itself, we didn't pass the parameter. See, that's a parameter, right? Command line argument. Remember in C++ Java, you guys wrote the main argc, argv. Many of you might remember. Argc, argv, that's what that indicates. What are the command line arguments? If you pass in, you can access that argc, argv to get that and process that. Okay? So, we'll revisit few of these things again, okay? So don't be too worried. Follow as best as you can, okay? Okay, so this is the input redirection operator, okay? And another operator, cat, okay, cat calendar dot text. So we want to know how many lines of this, how many lines are in this file. You have a pipe operator. Instead of displaying in the screen, send it as a pipe it into another command. Word count output length. Okay, word count, let's see. 8 lines. 39 words, 133 bytes. Okay, good. Lot of your typing. That's good. It can get pretty boring to watch. Okay, so that's why I suggested you guys to bring a laptop. Whoever didn't bring, next time try to bring, or work with somebody who has nearby. Have a buddy. Okay, okay. WC minus L. WC is word count. Even though the command says word count, it really counts lines, words, and characters. Okay, so you can do WC minus L, which is going to output only number of lines. Okay, so that's the pipe operator. Okay, kind of introduce a bunch of things in a hurry. So I do have one PowerPoint we can go through. Okay. That's a command too. Sleep 100. I think it puts the command line sleep for 100 seconds. It's waiting for that command. That's a command, right? Sleep is a command, so it's going to wait for 100 seconds. I don't want to wait that long. Control C. So let's put sleep 10. When you wait for 10 seconds, that does feel very long. Okay, so sleep 10. Now let's see what happened when I put a ampersand sign. You got the command prompt back. What we are saying is run this command in the background. It's a background task. It's not a foreground task anymore, it's a background task. Okay? Now it's done. See? So you can run something in the background. Yes?
Is that the process ID that it picks up?
This is a process ID, that's a job ID. Yeah. Yes? This is the number of lines, number of words, number of characters. Yeah, so in fact if you do ls minus L, it will show something to see. Number of characters are there. ls minus L is interesting output because it's a lengthy format. Remember let me do ls minus IL. Remember the directory itself, what does it have? Inode number and the file. That's all it has. Remember that directory? So where is this rest of the information coming from? Where is this rest of the information for the file coming from? Inode. Remember that inode structure? right? So you have inode number and the file name. For using the inode number, you can access the inode structure, right? Inode structure has all this information. Permissions, who is the owner, which group, what's the file size, the timestamp it was created, and all that. If you kind of refer back to that PDF, you will see all that information. Okay. So every inode, when it's doing, see when I do ls minus il, everything, for every inode, it's accessing the corresponding that inode block and trying to get that information, which means there's a lot of accesses, you know. So you see a simple structure just like that, but it's really resulting in various inodes it's accessing and outputting this information. Okay, so let's go back to our previous concept. Why would you need to run something in the background? Let's say you have a big number crunching job, right? Let's say it's going to take for hours, or processing really huge file. You can just run it a command in the background and just move on with whatever you have to do. Okay? Let's see, sleep 20 seconds, and then let's say I press Control D in the command prompt. What will happen if I press Control D in the command prompt? Just closes. I thought it will say error message saying that I have a background job. Sometimes I have seen that too. Okay, sleep 20. Let's see if I say exit. It does close. Okay, it doesn't seem to wait. Okay. So some systems I have seen, if you have background job, hey, you have a background job. Are you sure you want to exit? Basically, when you exit, it will kill the task. Okay. That's another way to get around that. I don't know that I really want to dump that much on you guys, but you can do something like this. And pretend this is some meaningful command. Obviously, sleep 20 is not very meaningful command. Think of something that you are doing, you're a researcher, you're doing a lot of data crunching. That's what that is. So you can say this command. So what do you think that expands to? People who already know Linux very well cannot answer. Give a nice expansion for that. No hub. What do you think it means? So that it will stay on even after you log out. No hang up. Don't hang up. When you get out, don't hang up. Continue and run. So this command, we don't want that to be killed even when I log out. What if this command runs for 2 days? I log in, start the command, I want to go away. Right? It will run, and it will hopefully store it in some output in the output file. Right? There's nothing to display, right? No screen to display, so you can store it in the output file. Okay? You can issue a command like this: no hub, some file name, some input, some tool. Right? You're doing something, some input, some output file. Maybe I should say input. Like that. You can run it in the background and go take a vacation. Okay? It will run for a few days, maybe, and come back, with the results. Okay, so let's look into this operators a little bit more. I am sure few of you are a little bit confused about all this dump of various things. Let's see. Let's take it a little bit slowly and review the concepts behind that. Okay. Okay. Redirection. You know what, this may be a good time to stop my recording and restart, because it has some problems